Hello, geometers. This is Miss Backfish, and I am looking at segments and circles. In particular, when we have two chords, they meet inside the circle. Notice there's no degree symbols here. We're not talking about anything arc measure, angle measure. We're strictly speaking about the lengths of these pieces of lines, segments. Okay, so that's how we actually tend to group these, I guess is the better way to put it, is by where they meet. If they meet inside the circle versus outside the circle. This is two segments that meet inside the circle, and when they do, here is how I set things up. Oh, that's outside, sorry. Inside, here's how I set things up. Okay, when my segments meet inside the circle, I say, okay, one part times the other part of one of these chords, so 10 times 6, is equal to one part times the other part of the other chord. So 4 times 3x plus 2. It's really a way of setting up an equation that says these are proportional. So part times part of one chord equals part times part of the other chord. So I'm going to say 10 times 6 equals 4 times 3x plus 2. Okay, so 10 times 6 is 60. Then I can distribute and I get 12x plus 8. And I get 52 equals 12x. And I can divide both sides by 12. And I'm not going to get a whole number. I'm going to get 4 1/3, or I think, let's see. That's 13 thirds. Yes, 13 thirds. I could write that as a 4 1/3. All right. That might be a little bit harder to go back and plug in if I were to ask to give maybe the whole length of the chord or something like that, but not too bad. Just because it's a fraction. But fractions happen, so that's okay. We got to be ready to deal with them. See you next time.